did you find those two numbers?
Because I looked at this one and
What's this one?
I looked at 12
Okay.
and what was in front of it. And back I just doubled it, whatever makes 12 or 6.
So you divided 12 by 2, is that what I'm hearing? Okay. And then you did the same thing to 40. So like Anthony said, so Joe agrees with Anthony, he found a common factor between 12 and 40, and he divided by it to get another equivalent fraction that was smaller than 12 to 40. Is there another ratio that we could have written first? Royalty? 6 to 2, would that be equivalent? How would we get 40 down to 2? We'd have to divide by 20, right? Can we divide 12 by 20? No. We have to have a common factor, and just like fractions, do the same thing to both sides of the ratio. So what other common factor do we have besides 2? Joe found 2. Is there another factor, Bree?
I say 4.
4. Can we divide 12 by 4?
Yes.
Yes, and what will we get?
3.
3. Can we divide 40 by 4?
Yes.
Yes. And what will we get? Say it.
10.
Say it.
10.
10. So either one of these is correct. You don't have to write both of them. This is just so you can see. You could have written 6 to 20 or 3 to 10. How about if we scale up? Now we're scaling up. Who filled in the last 2 boxes of their table? Raise your hand. Who filled in the last 2 boxes of your table? Gibson, raise your hand. What did you get, Elijah? What did you get for these 2 values?
18 and 60.
You got 18 and 60. And how did you get 18?
I multiplied 6 times 2.
6 times 2. Well, 6 times 2 is 12, right?
So 6 times 3.
6 times 3. Why did you multiply 6 times 3? You're right, but why did you do that? Because it's the... Which column is it? Is it first, second, or third? It's in the 3rd column. He counted by 6s. 6, 12, 18. You could also say, I multiplied 6 by 3, right? Good. And on the bottom you got 60. How?
I multiplied 20 and 3.
Yes. He counted by 20s, 20, 40, 60. And since he counted 3 times, he's saying we multiplied 20 times 3 and got 60. Okay? Is there something else I could have written here? Another equivalent ratio that's larger than 12 to 40? Try and talk with your partner. Tell him what. Tell him what. You couldn't. Nice. Track the board in 3, 2, level 0. Okay. Anybody's partner have a really good explanation for why or why not? Anthony? Loud and proud.
My partner said is that, well, what I told him is that if I think Elijah is sort of right, but then I'm thinking how did he divide it by 12 to 40?
Well, Elijah counted by 6s on top and by 20s on the bottom. So yes, Elijah's right. But is there another equivalent ratio we could have written here? Is there another equivalent ratio that's larger than 12 to 40? Joe says no. Royalty? We put 80 on the bottom and 24 on the top because it's still equivalent, right? When we scale up, you can multiply by any number as long as you multiply by the same number on both sides of the ratio, right? This is a review of what we did yesterday. So when I scale up, what numbers, how do I figure out what to multiply by? What can I multiply by when I scale up? Turn and talk to your neighbor. Okay, so we're on the right track. Okay, track the board in 3, 2, and 1. Okay. Whose partner had a really good explanation? What do you think?
So for multiply by is like to see if it's equal to 60, you can multiply 7 times 30 because 2 times
Okay.
3 is 6.
So Juanita's talking about factors of 60. Right? 20 times 3 is 60. So we use those factors when we scale down. What about when we scale up? If I want to make this ratio bigger, are there some rules I have to play by? Yeah, there's one rule. What's that rule thing? Can I pick any number to multiply by? Yes. As long as, Dalen, as long as I can pick any number to multiply by, we agree there. As long as it's, yes, the same number on both sides. Okay, that's our C value, right? When we wrote it like this, 12 to 40, and let's use our second ratio, 18 to 60. Okay? We have a C value. Multiply by the same number. Look at exercise 3 on your page. I need someone to read that for me. Read it for me, Zoe. What? Exercise 3 on page 55. Read it for me. Huh? A 1 liter bottle of cola.
That's a Coca-Cola.
Fine. Contains approximately.
34
Uh-huh. What's the question? How many
grams of sugar would be in 1 liter bottle of Coca-Cola? Explain and show how
How to arrive at the solution.
Yeah.
So how many grams of sugar are in 1 liter, which is 34 ounces? What do we have to use? What do we have to use to solve this problem, Jocelyn?
The ratio.
Yes, the ratio table that we worked with in exercise 1. Because what are our values in exercise 1? Or exercise 2, sorry. What two quantities are we comparing, Bree?
We're comparing Coca-Cola ounces and sugar in grams.
We're comparing cola in ounces and sugar in grams. Okay? So we have to figure out how much sugar is in how many ounces of cola, Lucas? 34, right? 34 ounces. Well, is there 34 on our table?
No.
No. Let's see, Elijah counted by 6s earlier, 6, 12, 18. Can we get to 34 that way?
No, it's on my forward.
No, right? 34 is not a multiple of 6. So what should we do? I'm going to give you 2 minutes. Turn and talk with your partner. See if you can figure out how many grams of sugar and 34 ounces of cola.
Okay, let's see. Let's start by 2. Let's see. 34 divided by 2. So how many I can't do that here.
Okay, Harper, give me 5. Cut our time a little bit short, hands down. We're getting a little stuck, right? What part is frustrating you? Elijah, thank you for volunteering.
The part where we can't find the 34 is in a type
Because we're working with multiples of 6, we don't have a 34 in our table, even if we extend it. Right? Yes, ma'am. Right? When you have to find how much sugar is in 34 ounces, because we can't find 34 ounces. Right? Did you have another? Oh, up here. Working backwards. You find the common factor, right? Just like a fraction. Okay? Talk to me about that in dismissal. Okay. So even if we extend our table, what would come next? Zoe, what would come next after 18? We're counting by 6s. So 6, 12, 18.
24.
Uh-huh. Then what? Tristan, what comes next? Uh-huh. And what comes after 30? Gianna? 36. Okay. How about sugar? We're counting by what, Michael? For grams of sugar, we're counting by 20s. So 20, 40, 60. What comes next, Michael? 80. Javier, what comes after 80? What comes after 80 if we're counting by 20s? Joseph? 100. Uh-huh. And our last value, if we extend our table to 36, Elijah? 120. So like we said, 34 doesn't live on our table if we count by 6s. Where would it be if we did have it on our table? Where would it be, Zoe? Between 30 and 36? Yeah, it would live somewhere in here, right? So the amount of sugar is between what two values? Valerie, what do you think? Between 30 and 36, you find 34 ounces of cola. So between what two values, grams of sugar, could you find the answer? Remember, these two are associated. This is a ratio and this is a ratio. So if we did have 34 in our table, between what two amounts of sugar could we find our answer? Babe, help her. Okay, she says 118 because that's right in the middle, and 30, yes, I see where you're going. But for now, we're gonna say between 100 and 120, okay? Yeah, good, no, you're thinking outside of the box, don't apologize for that. Okay, so today we're gonna use something called a double number line diagram. What? Okay, give me 5. Hands down. Take a deep breath. Okay, we're learning something new for a reason, right? We can't solve this problem with the methods that we know so far. So just like when we worked with fractions, I'm going to give you lots of tools so you can decide which one to use, which one is appropriate for the problem you're working on. Okay, so a double number line diagram is super cool because it's like a ruler. Raise your hand if you've seen a double number line diagram before. Nope, just a couple. Okay, Juanita, what's a double number line diagram?
It's like you have like 2 diagrams in one.
That's kind of like you have 2 in 1. 2 what?
2 tape diagrams.
Tape diagrams?
That like put it together in one.
Jocelyn?
2 ratio diagrams.
2 ratio diagrams.
Like
Okay. Bree?
We have 2 number lines.
2 number lines. Why 2? Why 2 number lines? Well, look at your table. Look at your table and talk to your partner about why we need 2 number lines.
Oh,
Go ahead.
because we need to find how much cola and ounces and sugar and grams.
Yeah. How many different measurements am I talking about? Because them on the same number line? No, because I have to have. Separate, just like we do in the table. Yes, go ahead. Okay, let's talk about it. Track the board. I'm waiting on 3. 1. Okay. So exercise 4 says a school cafeteria has a restriction on the amount of sugary drinks Drinks may not have more than 25 grams of sugar. Based on this restriction, what's the largest size cola in ounces that the cafeteria can offer to students? Okay, so we're moving up to exercise 4, or down. Okay. How much sugar can we have?
25
25 what?
grams sugar.
25 grams. Okay, are we going to use our table for this one? We're going to use our table from exercise 2 for this one? Sienna, are we going to use our table from exercise 2 for this one? Yes. Why? Why do we need that? Because, why, Gibson? Why do we have to use a table for this? Turn and talk to your partner. Why should we use a table?
How much cola in ounces can a school offer to students?
Yes. Okay, track the board. We need to refer to our table. Why, Tristan? Why do we have to look at our table? If we can have 25 grams of sugar and the question says how much cola in ounces can we have, Dima? We have to look at the table and see how many grams are in a certain amount of ounces. Right? This problem doesn't give us enough information alone. So we have to look back at our table in exercise 2. And we're going to use a double number line diagram. Why? We're going to use a double number line diagram on exercise 4 because
Because we want to find what is the largest size cola in ounces that the cafeteria could offer to the students.
But what about our value for sugar, Derek? Is this a multiple of 6? No. Is this a multiple of 20? No. We counted by 20s in our table for sugar. So if we count by 20s, do we get 25 grams on our table? No. Can we find it on our number line? What's halfway in between 20 and 40?
25.
What's halfway between 20 and 40? Say it.
30.
Raise your hand if you think it's 35. 25. 30. Haha. Yes, 20, 30, 40. Oh. Okay. Because 30 is right in between 20 and 40. So we can break up the numbers in our table on a number line, right? Well, let's fill in the top. Ounces, right? What's my first value?
6.
4. Who said it? 6. If I'm counting by 6 is what comes next? 6,
12.
12,
18. 24.
Okay, now we're looking for 25 grams of sugar. Where does that live on our number line, Faith? Where would 25 grams be? Well, we're looking at grams of sugar, not ounces of cola. So grams of sugar. Where would that live, Aiden? Well, we're looking at grams, though. It's asking for grams of sugar. We have to locate that first. So it's on the second number line, right? That's why we write ounces for the top one and grams for the bottom one. Okay. Exactly between 20 and 30. If you haven't drawn this on your workbook, page 55, under exercise 4, do it now. Drawing your workbook. Okay, so if 25 is right here in between 20 and 30, sorry Elijah, where can we find the answer for how many ounces of cola that has 25 grams of sugar? Where can I find that? Raise your hand if you can show me on the whiteboard. Jesslyn. Find it for me. So we found 25 grams of sugar here, but the question says, how many ounces in cola will that be? What? Tell me what? Are we looking for 25 ounces or 25 grams? Okay, so where do we find 25 grams on our number line? Derek, Trey? You're tracking, Derek? Circle 25 25 grams on our number line? Yes. So where would the number of ounces for 25 grams of sugar be? Oh. How do you know that? Yes, because just like, thank you, Derek. Awesome, thank you. Just like a table, when we use a double number line diagram, our value is right across from what we know. What we want is right across from what we know. So here's what we need, right? What did we do down here to find our 25? What did we do down here, Gianna? We looked at the amount of grams of sugar, and we only had 20 and 40. We knew it would be somewhere in between. What did we do first? We found 30. We put it in half. We found 30. And then what, Dalen? How did we find 25 on the bottom? What did we do? We cut it in half, and then what? Yeah, be confident. You know the answer. Say it loud. We cut it in half again, because 25 is halfway between 20 and 30. So we have to do the same thing on top. Just like when we reduce our ratios by dividing, it works the same way when we draw it, okay? We divided these two values in half on the bottom, so we have to do the same thing on top. If I put a line right in between 6 and 12, what is that value? Talk to your neighbor. Talk to your neighbor. Halfway between 6 and 12.
Halfway. What's close to 6 and 12?
10. Level 0 and 3, 2, and didn't even need the 1. Nice. Raise your hand if you